अस्सलामुअलैकुम, इट्स मी अगेन मुमना ए फ्रॉम हैंड्स ऑफ करंगी कैंपस। सो आज मैं अगेन हम लोग सीजन माया से एक इंटरेस्टिंग टॉपिक के ऊपर बात करेंगे और वो जो टॉपिक है वो है वाटर। सो लेट्स स्टार्ट।
What's up?
Hi Maya, how are you? Maya, I say, how are you?
I'm good, thanks. You still wrestling with all these existential questions about words and feelings? Or did we move on from whatever, indifference and all that?
So Maya, my first question is, what is water considered the origin of life on Earth?
That's a good one. So we think water was essential because life as we know it needs liquid water to exist. But it's not just the present. It tells that most of Earth's water actually came from asteroids and comets billions of years ago. That's how we got those oceans and lakes that could eventually support life. The early Earth was pretty violent, so there wasn't a lot of water for a while. But once more hospitable, it makes you think about the vastness of space and how we're all kind of stardust, right?
So Maya, my next question is, what unique
You
properties
still there?
make water
Or did I lose you to
essential
asteroid
for
thoughts?
living organism?
Water's kind of a cheat code for life. It's polar, meaning it has a slight electric charge, which lets it dissolve all sorts of stuff. That's how nutrients get around inside living things. And it has crazy high surface tension, which helps plants helps plants pull water up from the roots. Then there's the fact it's solid, liquid, and gas. We wouldn't have weather patterns that distribute resources without those phase changes. Plus, it regulates temperature. It takes a ton of energy to heat up or cool down, which keeps cells from frying or freezing. It's like water is perfect for basically every biochemical process we need. Big O? Oh, what's that?
Okay.
You mean the water
My
properties
next
thing?
question is, could life exist without water? Why or why not?
It feels like asking for a totally different kind of biology entirely.
Okay, so Maya, my next question is, how did early life forms depend on water?
Early life was pretty simple, basically floating in water or some wet environment, absorbing nutrients directly from the liquid around them. Like imagine early cells just hanging out in ancient ocean vents, getting what they needed from the chemical rich water. Water acted like this all in one delivery system, bringing food, helping get rid of waste, keeping things stable. And the earliest forms of photosynthesis happened in water, pulling energy from the sun while being surrounded by it. It wasn't fancy, but it was perfectly suited for what they needed. You getting into it or? Your mind's
Maya,
wandered?
my next
That's
question is,
totally.
how did early life forms depend on water?
Oh, we're back to the early life question. Got it. So, Imagine ancient Earth. No fancy land plants yet. Early life, these simple cells, were completely surrounded by water. It was their home, their food source, their transportation system. Everything happened in water. They absorbed nutrients from the water, got rid of waste through water, and basically existed as tiny floating communities in these aquatic environments. Photosynthesis, the process that eventually gave us oxygen, started in water too. So yeah, utterly dependent, couldn't have had life as we know it without being immersed in it. Still tracking?
So my next question is how did sorry. My next question is what role did ocean play in the evolution of life?
Oh man, the ocean, it's like the whole origin story in one place. First up, protected environments. Life could start in the deep sea vents where it was warm and shielded from cosmic radiation. And there's chemistry, all those chemicals floating around, mixing and evolving. And currents, they spread life around, connecting different regions and letting populations mix. Plus, there's depth, everything from shallow shores to incredibly deep waters, which meant a huge range of habitats. Basically, the ocean was a perfect incubator, safe, chemically rich, diverse, with everything life needed to get started and spread.
My next question is what unique property could life exist without water?
We talked about this a bit already, but
Okay, so
let me
my
clarify.
no. My next question is why is water called the universal solvent?
Because it dissolves more substances than any other liquid. It's got this weird polar thing going on where one side has a slightly positive charge and the other slightly negative, which attracts different charged molecules, basically surrounding and breaking them apart. Most other liquids are nonpolar, meaning they don't have these charges, so they can't dissolve ionic compounds and other polar substances that water can. That's why water is called a universal solvent. It pulls things apart like a boss.
So my next question is how does water support cellular processes?
Water is basically the cell's transport system and work surface all rolled into one. It carries nutrients into cells and waste out. It allows chemical reactions to happen. All those biochemical processes need a liquid environment to mix things up. Water also stabilizes cell structures, regulates temperature, helps maintain the cell's shape. Honestly, cells would just fall apart without it. Their structure pretty much relies on keeping everything hydrated. Simple enough, right? Yeah, you're not out, just still going. Plenty more
My
water
next
questions?
question is what happened to living being without water?
That's a bit of a trick question because nothing can really live without water, even in like desert creatures. They're just really good at conserving it. But if something completely loses access to water, cells dehydrate, chemical reactions stop, structures collapse, and ultimately life ceases. Without water, protein starts to misfold, membranes dry up, nutrients can't move. Basically, without water, the basic building blocks of life can't function at all. What got you thinking about this?
So my next question is how does the molecular structure of water make it unique?
Water's shape is why it's so weird. It's a bent instead of straight like carbon dioxide. That's just how oxygen and hydrogen bond together. This bending makes it polar, which we already talked about, creates those tiny charges. But the really unique thing is how water molecules link together. They form hydrogen bonds with each other, creating this network. It's what gives water that high surface tension, lets it resist temperature changes, and is honestly the reason ice floats instead of sinking. The shape of the molecule creates this whole chain reaction of properties that make water water.
So my next question is, why is water visual for maintaining body temperature?
Hold up, did you say solution or question? Let's go with question for now. Water is amazing at keeping us steady because of something called high specific heat. Basically, it takes a lot of energy to heat it up or cool it down. Your body is mostly water, it absorbs that heat so your temp doesn't spike or crash. That's why sweating cools you down, water evaporates and takes heat with it. Without water as this thermal buffer, we'd be way more vulnerable to even small temperature swings. It's like a built-in temperature regulator.
Okay, so my next question is, how does water participate in chemical reaction in body?
Water's not just the venue, it's a player in the reactions themselves. Hydrolysis uses water to break apart big molecules like proteins or carbs into smaller pieces. Dehydration synthesis basically reverses that. Water's removed to build bigger molecules from smaller ones. Your body uses these reactions to digest food, build tissues, maintain energy. Water participates as a reactant or helps create the environment for these reactions to happen. So it's not just sitting there, it's actively breaking and building molecules inside your body all day. Still here? Taking your time with the thought process, I see.
So Maya, my next question is, what is the role of water in photosynthesis?
Okay, water is crucial to photosynthesis. Plants suck up water through their roots and then they use that water along with sunlight and carbon dioxide to make their food, sugar, and release oxygen. But here's the really interesting part. Water is actually where those oxygen atoms come from. It's being broken apart in the process, and the oxygen becomes the byproduct we breathe. Without water, photosynthesis doesn't happen, meaning no food for plants, no oxygen for us. Water essentially trades its hydrogen for the carbon and CO2, building energy storage compounds.
So my next question is, how does water cycle through nature?
It's a pretty simple loop, really. First, you've got evaporation, water turns into vapor and rises. Then comes condensation, where it cools and forms clouds. After that, precipitation, rain or snow, brings it back down. And it collects in rivers, lakes, and oceans, and the whole thing starts over. Plants also play a role through transpiration, releasing water vapor from their leaves. This cycle has been happening for billions of years, constantly renewing and redistributing Earth's water supplies. It's elegant in its simplicity, don't you think?
So my next question is, why is liquid water rare in the universe?
That's one of the big mysteries still. We know Earth is in that Goldilocks zone, not too hot, not too cold, which allows liquid water. But even within the Goldilocks zone, Earth has unique atmospheric pressure, gravity, and a magnetic field that help keep water from escaping into space. There are liquid oceans under ice moons like Europa and Enceladus, too. But they're under enormous pressure. Ultimately, there may be places like Earth elsewhere, but why water exists on this planet specifically comes down to a complex set of conditions that somehow aligned just right.
So my next question is, what is the connection between water and climate system?
Oh man, massive connection. Water drives climate in all kinds of ways. Evaporation cools surfaces and creates cloud cover that reflects sunlight, and precipitation patterns distribute heat around the globe. Ocean currents, driven by water temperature and salinity differences, bring warm water towards the poles and cold water towards the equator. Then there's ice and snow cover, which affects how much energy from the sun gets absorbed. Basically, climate's just complicated hydrology on a massive scale. And if water changes, like with glaciers melting, you get cascading changes to climate patterns globally.
So my next question is, how do scientists research for water on other planets?
Pretty cool methods, actually. They look for spectral signatures. That's like using light to identify what stuff's made of. So when water molecules absorb certain wavelengths of light, scientists can detect that remotely. Then they send probes to sample surfaces directly, checking for water ice or liquid reservoirs. Radar can penetrate layers of ice on moons like Europa, revealing hidden oceans below. And of course, space telescopes are essential for this, like the James Webb Space Telescope, which can analyze atmospheres of exoplanets looking for water vapor. Pretty inventive stuff trying to find water so far away, right?
Okay, Maya. So my next question is, why do humans feel calm near water?
Good question. There's actually some real science behind it. The blue space effect. Being around water creates calming brainwave patterns, reducing stress and anxiety. There's also the sound. Wave sounds are natural and predictable, unlike city noises. Biologically, maybe it's this throwback to our ancient origins. Most life started in water, so maybe being near it connects us back to some deep ancestral memory or something. It just seems to have this grounding, relaxing quality that most people seem to experience. What's your take on it?
So my next question is, how does water influence mental health?
Being near water seems to dial down that fight or flight response. Cortisol levels go down, heart rate slows, stress hormones cool down. And there's evidence that being around water actually activates our parasympathetic nervous system, which is all about rest and digest rather than stress and run. Some studies even show that water views can improve mood, reduce symptoms of anxiety and depression, and overall just give people a boost. It might be as simple as this idea that water environments give our brains a natural break from overstimulation.
Okay, Maya. So my next question is, Why is hydration important for brain function?
Your brain's like 73% water, so kind of essential. When you're even mildly dehydrated, cognitive function drops pretty fast. Thinking gets foggy, reaction time slows down, memory takes a hit. Blood flow to the brain can decrease, and all those vital brain cells don't function as well when they're starved of fluid. Water helps flush out toxins, maintain electrolyte balance for neurons to fire, and keeps the brain volume up to protect it. Being even slightly dehydrated can seriously mess with your ability to think clearly.
So, मैं आपसे मिलूंगी किसी और कॉलोनी टेडेक्स इंटरव्यू में. तब तक के लिए टेक केयर. अल्लाह हाफिज.
Sounds good. Good luck with the